So calculating the percent composition, sometimes called percent composition by mass of a compound, is actually a pretty simple understanding. A percentage is, of course, a part to whole ratio. And to express it as a percentage, we then multiply by 100, and that's how we calculate any percentage, and that's true of percent composition of a compound. We're going to take the part of the mass that is a certain element and divide by the whole mass. So as a simple example of what I'm discussing here, let's take hexene, which has the chemical formula C6H12. Part of the mass of this molecule is, of course, carbon, and part of the mass is hydrogen. And of course, carbon atoms have very different masses than hydrogen atoms. Carbon atoms are 12 times bigger than hydrogen atoms, so they account for more of the mass than the hydrogen would. But nevertheless, if we calculate what part of the mass is carbon, it has 6 atoms, and they are each 12 atomic mass units. Carbon makes up 72 parts of the whole mass of hexene. Hydrogen, on the other hand, with its 12 atoms that are each only 1 atomic mass unit, makes up the other 12 parts of the mass, and the whole mass is 84. So of course, if the percent composition is the part to whole ratio of carbon to whole and hydrogen to whole, all we do is take the part, 72 units of mass of carbon, and divide by the whole, 84 units of mass, that is the entire compound. And when we multiply by 100 to get an actual percentage, we get 86% carbon by mass. So of course, there are two ways to calculate the percent by mass of the hydrogen in the compound. We could either realize that if this is one part and there are only two elements, the other part, 14%, must be hydrogen, using the law of unity. The two parts have to add up to the whole. Or we could do the same thing for the hydrogen that we just did for the carbon. Take the part of the mass, 12 atomic mass units, and divide by the whole mass of the compound, 84. Multiply by 100, and with two digits you'll get 14 this way as well. As a second example, what if we wanted to know the percent by mass of, say, magnesium phosphate? Well, first we need to know the formula, because essentially we're using formula masses as the whole in our part-to-whole ratio. But we also have to consider how many of each atom and the mass of each atom to figure out the part of the mass. So the correct formula for magnesium phosphate is Mg3PO4 2, meaning we have two phosphate ions, each containing a phosphorus and 4 oxygens, and 3 magnesium ions. Well, that means magnesium, with 3 atoms, each one of them being 24.3 atomic mass units, accounts for 72.9 of the mass units in magnesium phosphate. Now, of course, the phosphate ion has two components. It has a phosphorus atom and 4 oxygen atoms. So that really means we have 2 phosphorus atoms in this one formula unit, and 2 phosphorus atoms, each 31 atomic mass units, would account for another 62 atomic mass units as the part that is phosphorus. And of course, the oxygen atoms are the most prolific in the compound because there are 4 in each ion, and we have 2 such ions. That accounts for 8 oxygen atoms at 16 each, which comes out to 128 atomic mass units of mass, giving us a grand and glorious total of 262.9 atomic mass units. Now, of course, to go ahead and then calculate the percents by mass, the part that is magnesium is 72.9 mass units, and the whole, 26.29 mass units, times 100 means that we actually have 27.8% by mass magnesium. And then further still, if 62 of the parts out of the whole 262.9 are phosphorus, it means phosphorus accounts for 23.6% of the mass of magnesium phosphate. And finally, if the oxygen accounts for the majority of the mass, 128 of those 262.9 atomic total mass units, it means that oxygen is 48.7% by mass of the compound. And so if you are asked to give the percent composition or the percent composition by mass of a substance, you would simply use all the part to whole mass ratios adjusted for how many of each atom and the mass of each atom, and make it a percent by multiplying by 100. Same was true of our hydrocarbon. Take the part to whole ratios, multiply by 100. Of course, we need a correct formula to do this correctly.